Okay, in this video, we're going to step through the process of inventing one possible language for this machine, a machine language that will operate this universal crystal generator. Now, there's virtually an infinite number of possible languages. We're interested in trying to find the optimal one that can allow us to create a language that will do simple math, which will move from point A to point B. Um, Now, when we start to name things, we break the symmetry. So for instance, this is perfectly symmetrical, so there's no information on it. Now, if we were to name this one green, then not only do we have a specific point that we can identify, but we create sets like its three closest neighbors, its three next closest neighbors, opposite point. So as we name, we break symmetry, and as we break symmetry, we create information. As we create information, we create sets. So what our objective is to create sets between these two perfectly symmetrical objects that will be optimal for operating a machine like this. So the first thing we need to do is get a handle on how many things need naming. We need to name the 8 points of this cube, and we need to name the 20 points of this dodecahedron, and we need to be able to name locations and positions and orientations and all of that all at once. So we know that we've got 20 points on the dodecahedron. Any of the points of the cube can go on a point. There are 6 rotational locations for each cube, so that makes 120 cubic orientations. And there are 2 tetrahedral readings for each cube, so that's 240 tetrahedrons. So we need to name 20 locations with 240 names for those locations. So, and we want to do it in the most optimal possible way. So the first question we need to ask is, how many points on each of these objects are required to specify that object? Well, the answer is 2 for each. So in order to specify a particular tetrahedron, we need point 1 and point 2, and the same goes for the dodecahedron. So we need to have names for 2 points on this and 2 points on this. Well, if we just cut to the chase, we can see that this is perfectly viable for those purposes. So for instance, now if I want to do math with this, simple math like addition, when I do it on a number line, what this means here is this is a location, this is a location, this is an operator, and this is a script. This script says plus plus, okay? This is different than this. This says go here, this says go here, this says do this. So when I do that on this, I need to name this point and this point. So in this case, I can take 3 faces and say green, 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 and that means the green one is on green, 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 and red, red, red. That means the red one's on red, red, red. So I could say green, 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 red, red, red. That means this location. And then I could say, well, I want you to go to this location, which is red, red, blue, yellow, yellow, blue. So green, 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 red, 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 move to red, red, blue, yellow, yellow, blue. Well, it doesn't take much imagination to know that green, 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 red, red, red is the same as 2 codons. So we can name any location with 2 codons, and we can also name any path with the same symbol. So we could say green, 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 red, red, red. Well, between any 2 locations on this thing, there's always a path that's 6 steps long. So 2 codons plus 2 codons equals 2 codons. So if we get the full the full code, we can see that this machine language can be operated by the molecules in this table, which means that the genetic code is the machine language of this machine. And this machine was built as a universal crystal generator, which means that the genetic code is a universal crystal generator. This is not a theory. This is a mathematical fact that we just mechanically demonstrated. So this kind of makes sense out of what this thing is doing, okay? It's not necessarily making sequences. It's manipulating space through time. It's a logical code. This is a codon table right here that doesn't have any molecules in it, okay? The molecules evolve to be in the table. The molecules don't make the table makes the molecules. So we need to start thinking of life, or the language of life, as a machine language that has spatial functions. It's using spatial information and code scripts to change space through time, okay? Once again, this is not a theory. This is a mathematical fact, and we can map the actual data from the codon table to a real codon table. This linear thing, monstrosity, has no codons. Okay, this table starts with codons, and then we name the molecules with the codons. Okay, that's the way a code works. You don't take the values to name the variables, you use the variables to name the values. So there's a lot of things that we can interpret into this, and we should and we will, but the first thing we got to realize is this really is a code. It actually has a function. It functions as a mathematical language of spatial logic. Life is logical. It has a code. So we still have some work to do, okay? We need to invent a universe that can invent this machine. So we'll get busy on that in the next video.